Hello, I'm Dawson Saunders, and this is the Compression Molding Alternative Lab Assignment for ETM 2080 Industrial Plastics. Okay, so the first part we're going to be looking at is the shot glass. So the shot glass was in the press for 4 minutes at 225 degrees Fahrenheit for temperature. That 225 degrees Fahrenheit also applies for the preheating of the mold. And then for pressures, the current chart said 5,000 psi, but that would max out the machine. And in the video, it only got up to 3,000. Raw material, 2.5 ounces of phenolic. Methods of measurement are the gauges, thermometer, and timer. The mold condition for the shot glass was poor, not in the regard that it was very dirty and had a bunch of residue on it, but more that people were using metal tools, and that's why it stuck to the mold. And as you can see, it's pretty well damaged. Machine designation. All this work was performed on machine B, and then for part defects here, you can see it didn't really form on the edge at all. And then, like I mentioned earlier, with the mold it being stuck, you can see where you hit that little you hit that tab, and it just kind of kicked this little piece out over here. So, and that's just from the surface being tore up from people using metal tools like you're not supposed to. The next part is the square cup. Right off the back, we have changes from the shot glass in regard to processing time. There was no time given in the video, but just watching the video and watching the time bar at the bottom, this part was only in the press for just around a minute. However, it was the same temperature, but this one actually had more pressure at 4,000. This one also had more material at 3 ounces. And then the methods of measurements are gauges, a thermometer, and a timer. That's the same for all 3 parts we'll be seeing. This mold condition was fair. The part came out with ease. There wasn't a lot of residue or scratching. And then the same for all 3 parts. Its machine designation was B. And then as far as part defects go, you can see where the actual part itself has a very porous surface. It actually seemed like you can see like the little bits of phenolic all throughout, which is not what we want. And that's just from the lack of time. It was on the heat in the press. It just couldn't fully heat up all the way to melt. You can see like some parts like kind of formed right here, but then if you look at like this edge right here, you can clearly see the little pellets of phenolic. And then the other part defect is just a good bit of flashing. I actually didn't know what flashing was until now, but it's actually just this all this excess material or overfill that's just known as flashing. For the third and final part, and the part that I think turned out best in my opinion, is the NFL logo. So the processing time with it for this was 4 minutes. It was in the press. The temperatures were same as the last two at 225 degrees Fahrenheit. The pressure for this part was 4,000 psi. The raw material was a little bit was actually the least out of all 3 parts at 2¼ ounce of phenolic. The method of measurement is the same as the last 2 with the gauges, thermometer, and timer. This mold condition was fair as well kind of similar as the last one, where there wasn't really anything on the surface, and the part came out pretty easy. Uh, Similar to the last two, this was all done on machine B, and similar to just the last part, you can still see we have some of that flashing just all around. This edge is okay, but there's still some excess. But other than that, this part turned out very well. The bottom cured up pretty good. You can clearly read all this, which is good. This is just the part that came out the best, in my opinion. Okay, so now that we've seen all the parts, these are the 4 things I found important to ensure a good part. Number 1, just be that you work fast, and I say that just because um, with the temperatures and the cooling and everything, you don't have to go super fast, but you're going to get a better product if you're able to work fast and efficient. And then number 2, this is very important. Your part has to be in the middle of the press when you're heating and compressing. If not, it would twist the mold kind of funny, and you just wouldn't get a very good part. For number 3, this was number 3 was performed on the last part, and in my opinion, I think it helped make that the best part, and that would be putting the pressure on and then basically releasing that pressure or burping, just letting that steam out and everything. It helped make a better part. And number 4, I say kind of reluctantly, just due to the fact that only the first part had grease, had the mold grease in it, and that was actually the only part that stuck. The other 2 parts didn't have it, and they came out with somewhat ease. But I don't think it would hurt to put some grease mold just in every, or to grease the mold for every part, just to help out a little bit in getting the part out. For the final section of this presentation, I have my opinion on how to improve the process. I found there to be 3 biggest factors and or variables, I could say, that change throughout the video, and that would be the amount of material used, the amount of time in the press, and the varying amounts of cooling time. So with that being said, test 1, 3 samples using 3 similar molds, and varying amounts of material or phenolic. We had a different amount of material for every part, which is understandable because the molds and parts are going to be different sizes. But at the same time, you have, like with the last 2 parts, we had that flashing, just that overfill. And the numbers we used were on the current chart. So just to test those and maybe update that chart a little bit won't hurt at all. And then the same thing with time. So 3 samples using 3 similar molds and varying amounts of time in the press. There's for the first part, I know the chart said 4, and then I believe something else said 5 minutes. So just narrowing down that time scale a little bit, probably ensure a better part. And then for the last, speaking of time again, 3 samples, 3 similar molds, and varying amounts of cooling time. I know for the second part, it literally had no cooling time at all. It was just taken right out of the mold. Okay, so with the results from the 3 tests, in my opinion, these are the procedures we should implement. The first of those being these molds. Some of them are in okay condition, but you can tell they've had their use over the years, and even worse, people people have been using metal parts on them, and you'll get what you got with the first part where it was stuck to the mold and didn't really want to come out. And then the second procedure is with the results from the test, selecting the proper amount of material and time to use. Basically, so just kind of updating that chart that was present in the lab. And then the third thing, not really as important, but I think it would help. Machines need to be labeled. The only way to designate between machine A and machine B was the fact that machine B didn't have a some sort of lever. It was, or that's how it was distinguished in the video. But it wouldn't hurt to put some labeling on them, and maybe also the presses look kind of dated, so maybe retrofitting with some new parts, installing stuff like new gauges, maybe a built-in. Well, it had the temperature gauge, but maybe putting in a time gauge, stuff like that. And then last but not least, we have what is wrong with the current process, and just two things I saw that really stuck out to be wrong. The first of those being, like I mentioned, the molds need to be replaced. Just you can't have. It's clear people have used metal parts on them over the year. There was actually metal parts used on. Well, I mean the first mold was already damaged, but in the video, metal parts were used. So just replacing those molds would not only make the process more efficient by making the molds easier to remove, but also just ensuring a better part. And for the second part, this seems to be the common theme with all of these alternative lab assignments. The charts just seem like all the charts, in this case the one with the temperature, the time, and the pressure, they just seem like they kind of need a refresh. Like it seems like these numbers could work, but they could also at the same time be improved to just help get a much better part. And that is all for this presentation.